In today's lesson, we're going to explore on more of our compound interest formula as we did from the last lesson, except we're just going to calculate for the other values other than the future value. But let's start off with a warm-up. So here's our question. I want to start saving for a Porsche for when I retire in approximately 20 years. I put $75,000 of my hard-earned money into an investment that will pay me approximately 3.2% compounded annually. Compounded quarterly. If a Porsche costs approximately $250,000, will I have enough money in my investment to pay for the Porsche by the time I retire? Well, how we go about calculating that question? Again, our compound interest formula is future value is equal to the present value times 1 plus I to the power of n. So let's list off what information that we have. So here I have 20 years, so time is 20 years. I initially put in $75,000, so that's my present value is $75,000. Investment that will pay me 3.2% per annum compounded quarterly. So per annum means that's the interest rate per year, so that's the R is 3.2%. So let's write that as a decimal, 0.032. So, and finally it's compounded quarterly, so I gave that the variable C, and quarterly means that there's 4 payments per year. So how do I calculate I? I again is R over C. So in this case is 0.032 over 4, which is 0.008. And finally N, the number of interest payments we get is going to be C times T, which makes sense. The number of interest payments per year, that's the compounded quarterly, that's what that means. And then we have 20 years, so this is going to be 4 times 20, which is 80. So there's going to be a total of 80 interest payments during that time. So let's go off and calculate this. Future value is 75,000 times 1 plus 0.008, all to the power of 80. So the same thing as 75,000 times 1.008 to the power of 80. And then we don't want to take any intermediate steps in this. We want an exact answer because we're dealing with money in some sense. So once we plug that in the calculator, we get a total value of $141,874.33. So I'm going to be well shy of being able to afford my Porsche in 20 years. So therefore, he's not even going to be close. So in this lesson, we're going to use this example. In fact, for the rest of the unit in some sense, we're going to use this example to sort of what are the different investment options and different ways that I can sort of get my Porsche by the time I retire in 20 years. So the success criteria for today's lesson is we're going to calculate all the other variables in terms of our compound interest formula that we have up here. So the really lesson 1 was calculating the future value, which is what we've done here. But now we're going to be able to calculate what the present value is, given the compound interest situation, what the interest rates, and the number of compounding periods. So all the other variables as part of that equation that we'll sort of go off and sort of calculate for. So here will be another situation. Obviously, I need to find a better investment. So one way I could do that is find a better interest rate. So what is the rate per annum of the investment that is compounded quarterly that I must find in order to get my $250,000 Porsche in 20 years with
initial investment of $75,000. So let's go off and write our compound interest formula again. So present value, not present value, future value is equal to present value times 1 plus I to the power of n. And let's go off and sort of dissect our question and see what information we're given. So in this case, my present value is still 75,000.
My future value, for sure we want 250,000 by the end of all this. What else we're given? So 20 years, time is 20 years. Because I'm still looking for something that's compounded quarterly, my C is still 4. So the question here is, what is my interest rate? So that's the one that I'm looking for. So let's go back and plug this into our formula. So it gets future value is 250,000. It's equal to 75,000 times 1 plus I to the power of n. So n again was going to be t times c. In this case, it's going to be 20 times 4. So that really hasn't changed from the previous question. I'm still getting 80 interest payments through the entire time frame. So here we need to isolate for our power first, because well, our unknown is inside our power. So let's go off and isolate our power by dividing by 75,000 on both sides. So we're going to get 1 plus I to the power of 80 on the right. 250,000 over 75,000. Well, top and bottom divisible by 25,000. So this is going to be simplified to 10 over 3. And now, in order to isolate for the base, we need to take, in this case, not taking a square root, but since our exponent is 80, we need to take the 80th root. So good thing we have our calculators for this, because you take the 80th root of 10 over 3, this is going to be approximately 1.015. So in order to get for I, you need to subtract 1 from both sides. So I is going to be approximately 0.01. Oops. 0.15. So this is not the interest rate per annum. This is just the interest rate per interest payment. So remember we had this other formula where I is equal to the rate divided by C. So in this case, R is going to be I times C. So here in this case, the interest rate is 0.015, and we're getting paid 4 times a year, so that's 4. So here, R is going to be 0.06. So therefore, Mr. Tam needs to find an investment that pays 6% per annum, compounded quarterly. Okay, so that compounded quarterly is important because hopefully by doing your homework, we realize that depending on the compounding periods, this greatly affects our future value. Well, finding 6% these days is nearly impossible. In fact, to be honest, even finding 3.6 these days is nearly impossible for an investment. So the best investment I can still find is 3.6% per annum compounded. So this is a typo. It should not be monthly. Let's keep the question consistent. And it's quarterly. How much money must I invest now in order to get $250,000 for my Porsche in 20 years? So here, I can't get a better investment. So the best thing I do is sort of upload my investment up early, so I need to invest a greater amount. So here, let's go back to the original equation. Future value is present value times 1 plus I to the power of n. So in this case, my future value is still $250,000. The present value, that's the unknown, because I want to figure out how much I need to invest now. The interest rate is 0.036. My compounding periods is still 4, and my time is still 20 years. So here my I is going to be R over C, which is 0.036 over 4. So as we discovered before, this is 0.08. And then the number of interest payments is going to be time times the number of compounding periods, which is 4. So here is going to be 20 times 4, which is 80. So we've had a lot of these numbers before. We're just playing things around a bit to figure out the different values of other variables. So here my future value is 250,000. Don't know what my present value is. 1 plus 0.008 all to the power of 80. So here we're going to get 250,000 is equal to the present value of 1.008 to the power of 80. So in this case, I'm going to divide both sides by 1.008 to the power of 80. So type it all into the calculator all at once. And we get present value is equal to $122,080.62. So what this says is that I have to initially up my initial investment or my initial deposit in my savings account from $75,000 to $122,080.62. So therefore, Mr. Tam must invest $122,080.62 now to save up to $250,000 in 20 years. So that's a significant chunk of change, which unfortunately I don't have. So I'm exasperated. So I can't find a better investment other than 3.6 per annum. Again, this should not be compounded monthly. This should be counted quarterly. I still only have $75,000. I can't, as much as I beg, borrow, or steal, I can't get more than $75,000. So the only other option I have to have is time. I just have to wait it out. So let's figure out how long I have to wait. So we're still dealing with compound interest in this case. So present values, not present value. Future value is equal to present value plus 1 plus I to the power of n. So let's go off and decipher what we know. So future value is still $250,000. Present value still 75,000. Number of compounding periods, that's still 4. In this case, time is unknown. So therefore, n is unknown. Because remember, n was t times c. The other thing that we do know is our rate is 0.036 still. So that implies that my I is 0.036 divided by 4, which is 0.008. So really our unknown here that we need to figure out first before we figure out time is n. So here we're going to take the future value, which is $250,000. Is equal to 75,000 plus 1 plus 0.008 all to the power of n. So I'm going to take a couple of steps together at once. I'm going to divide both sides by 75,000. So on the left I'm going to get 10 over 3 again. And this is going to be 1.008 to the power of n. So again, how do we solve for our variable when it's an exponent? We need the logs. So in this case, n is going to be log of my answer, which is 10 over 3, over log of the base, which is 1.008. In this case, n is going to be approximately 134.37. So here, because we need n to be an integer, we need to round up. So this raise, really n is going to be 135. So I must wait 135 interest payments in order to save up to $250,000. So this has exactly answered my time, because we need to know how long will I have to wait. So we can go back to the other formula of t is equal to, well, the original formula was n is equal to t times c. So t is going to be n divided by c. In this case, it's going to be 135 divided by 4, which is 33.75. So I have to wait. So therefore, Mr. Tam has to wait 33.75 years to buy his Porsche. And hopefully he is still alive at that time. So even go through a basic example like this, where we sort of go off and experiment with the different values. One thing that hopefully might stick a little bit in terms of troublesome is that the Porsche is worth $250,000 now. Who knows how much it's going to be worth in 20 years time. So that's one flaw in this sort of exercise, is really I should be figuring it out, especially in all these situations where I'm waiting 20 years, is that their assumption is the Porsche is worth $250,000 in 20 years time. Let's say that is the case. Well, the real issue, the last problem is that I'm saving for $250,000, so that in 20 years, that's how much the Porsche is. But in this case, I have to wait approximately 34 years. So I probably have to save up for a little bit more, probably not a little bit more, a lot more than $250,000. And again, if I adjust for that, I probably have to wait a little bit longer than 34 years to do that, to do this correctly. So anyways, for homework, just a few questions, just going off for practice, calculating the various parts of our compound interest formula.